Okay, hi everyone. So let's just close some of these bits. So you might have noticed that what we were doing yesterday was kind of merging towards adding fractions as we were looking at bonds, basically, fraction bonds, a bit like number bonds. We're going to take that, extend that a little bit further today into adding of fractions with the same denominator and with different denominators. So yesterday we were looking at fraction bonds essentially. We all know number bonds. If I said here's a 10 frame and I've got 5, what do you need to add to 5 to make 10? You'd all be able to tell me quite quickly 5. Well, actually, what we were doing yesterday is no different. We had tenths and we've got 5 tenths. What do we have to add to 5 tenths to make 1 whole? Well, it's another 5 tenths. We could do the same. What do I have to add to 4 tenths to make 10? It's just like your number ones. What do you add to 4 to make 10? Well, you add 6, but in this case, we're talking about 6 tenths. And the same thing applies whether we're talking about sixths. So here's like a tens frame, but with a sixths frame, we could call it. So 1/6. Well, what do I add to 1 to make 6? The bond is 5. So 1/6 plus 5/6 make 6/6. So yesterday was pretty much number bonds, but in fractions. And that's sort of the building blocks to adding, which is what we're going to look at today. So back to chocolate, everyone's favorite. Green, is that dress? Let's just call it green dress, says, let's share this bar of chocolate. I will have 1 piece. Now, if you look carefully, we've got our bar of chocolate made up of 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. Or we could say parts. The whole bar of chocolate is made up of 9 equal parts. And green dress is having 1 of those parts. Yellow shirt, though, says that he's going to have 3 pieces, 1 entire row. So we could say we've got 1 row, 2 rows, 3 rows. So he's having 1/3 of this bar of chocolate. To start adding them up, we need them both to be the same type of fraction. So you can see our friends talking about it here. 1/9 plus 1/3 is not 2/9. It's also not 2/3. We've got to do some exchanging. We've got to change our fractions into similar ones, or have to at least have similar denominators, because in order to add, the denominators need to be the same. So let's start looking at this. I'm just going to bring this up to a picture because it's nicer to think about chocolate. 1/9 plus 1/3. Well, we know that we could call 1/3 3/9, because that 1 row is made up of 1, 2, 3 squares, 3 parts. So 1/9 plus 1/3 is the same as saying 1/9 plus 3/9. Now, when I start adding my ninths together, it's the same denominator. So I'm talking about 1 part of a chocolate split into 9 pieces and 3 parts of a chocolate split into 9 pieces. So I can do that simply by adding the numerators, and 1/9 plus 3/9 becomes 4/9. Really, really important. You can't just add the numerators if the denominators are different. The denominators must be the same in order to add or subtract the numerator. So it looks a bit crazy here, but just bear with me. Find the sum. We know sum means adding. Find the sum of 1/5, 3/10, and 2/5. It's not as complicated as it looks, because actually 2 of our fractions have the same denominator. 1/5 and 2/5 are both fifths. So we can do that. 1/5 plus 2/5, denominator is the same, so it's 1 plus 2. You can all do that without your fingers. 1 plus 2 is 3. So we know that 1/5 plus 2/5 is 3/5. Where it gets trickier is our 3/10. So what have I done with my arrows? Right, so what we've done is we've switched our 3/5 here into tenths. What do we know about the relationship between 5 and 10? Double 5 is 10, so 5 times 2 is 10. We multiplied our denominator by 2. For each of those 5 parts, we broke them in half to make 10 parts. So that means for each of those 3 bits of chocolate, we've broken them in half. We've doubled the amount. So we times 5 by 2 to get 10. We times 3 by 2 to get 6. So 3/5 is the same as 6/10. So now I know that I can add 6/10 to 3/10. I've done my arrows the wrong way around here. We can add 6/10 to 3/10. The denominator is the same, 10 and 10. So it's the numerator adding. 6 plus 3 is 9. So 1/5 plus 2/5 plus 3/10 is 9/10. Some of you might be thinking, oh, why didn't I just switch my 3/10 into fifths? Well, let's have a look. To do that, I'd have had to halve my denominator. I can divide 10 by 2, that's fine. But can I divide 3 by 2? I can't. I can't have 1.5 fifths. If I were doing just ordering, it might be okay to do that because that would give me an idea of its size, but I'm not, I'm adding, which means I need to be able to add it, and I can't add halves of fractions. So I had to convert everything into tenths. I could have turned this fraction into tenths by itself, 2/10. I could have turned this one into tenths, 4/10, and then added 2/10 plus 3/10 plus 4/10. That wouldn't matter. I'm still converting them all to tenths. But it seemed easier to do one conversion because there's less chance of making a mistake then. So by adding my fractions with the same denominator first, then converting them, and then adding them to the 3/10. Okay, I'm going to ask you now to pause the video and have a try at question A and B. So we're adding, in question A, we're adding fractions with 9th as the denominator, and B, we've got 10 and 5 as the denominator. I'll pause the video now and have a try. Brilliant. So, question A, that's quite simple because our denominator is the same. So we know that our numerator is going to be, our denominator is going to be 9, and our numerator is going to be 1 plus 4. 1 plus 4 is 5. So we know, forget that's an arrow. It's going to be 5/9. Bit trickier when we get to this question here, though. We've got 1/10 and 1/5. Well, I know that 1/5 is the same as 2/10 because if I double 5 and double 1, I get 2/10. So 1/10 plus 2/10 is 3/10. With my okay. And let's try 1/2 plus 1/4. Pause the video, have a try. Excellent. Hopefully you've all realized that 1/2 is the same as 2/4. 2/4 plus 1/4 is 3/4. Let's move on to the next question. There we go. Right, back to slightly trickier ones because there's 3 fractions here. Find the sum of 1/3, 1/6, and 1/12. I've drawn them out here just to kind of give you a bit of a visual idea of what we're doing. They're all unit fractions. First of all, what denominator are we going to convert these all into? Hopefully you've seen that the only denominator we could practically use is going to be 12ths. So I know that 1/12, that's simple. How many 12ths is 1/6? Yeah, we can see probably, hopefully you can see, it's 2 12ths. What about 1/3? If I follow it up, I know 1, 2, 3, 4. 1/3 is 4 12ths. So now I've got 1/12, 2, 3, 4, 5, 6, 7. So my total is going to be 7 12ths. Sometimes you'll find that drawing it out makes it a lot simpler, although we could have written this as a calculation too. 3 times 4 is 12. 1 times 4 is 4. So this fraction here becomes 4 12ths. 6 times 2 is 12. 1 times 2 is 2. So this fraction here becomes 2 12ths. However you worked it out doesn't matter. Right. I'm not going to give you an answer for this one, but I just want you to have a try of it. Be honest, give it a try, see if you can make this work. Find 3 fractions that add up to 1. If you're feeling less confident, you can have them all have the same denominator. If you're feeling more confident, try and use 2 different denominators. If you're feeling super confident, see if you can go for 3 different denominators. Once you've done that, play the video again, or in fact, don't play the video again. Once you've done that, can you then complete worksheet 8? The files are on the PDF for today. So when you completed worksheet 8, come back to the video and we'll have a look at the answers. Brilliant. So here's worksheet 8. You've got your answers for the first part. If you were struggling, I would really suggest drawing it out, either drawing them out or I've attached to the PDF each day the link to the interactive teaching program that helps you kind of put in your different fractions so you can see them visually. Sometimes that's easier, particularly if you haven't got squared paper. Okay, I'm going to scroll down so you get a chance to see them. Brilliant. And we're going to carry on with adding fractions for the rest of the week, in fact. So if it's not making total sense yet, don't panic. If you didn't get them all right yet, don't panic. We are going to come back to this tomorrow. See you tomorrow, guys.